Okay, let's take a look at this inequality. I'm going to factor this, find the zeros, and then do some test points to solve it. So this one I might get lucky. Instead of doing, typically we'd have to do the synthetic division since I got a cubic. But I think this one might factor by grouping. Let's try it. So I'm going to factor the greatest common factor out, and I'll factor out the negative. And that gives me a positive x, which is why I factored the negative out. So this term's positive, minus 2. Check that if you want. Negative x times x, negative x cubed, negative x squared times negative 2, positive 2x squared. Now, what can I factor out of? We're doing factor by grouping. What can I factor out of here? Nothing, but I can always factor out a 1 just to get the form I'm looking for. So that would give me an x minus 2. This allows me to factor like this. Factor out the x minus 2, and I get x squared plus 1 times x minus 2. And now what I want to do is factor this thing if I can. And notice if I factor out a negative 1, it becomes x squared minus 1, which I know factors as the difference of squares. Alright, so from here, you could do this by graph. I think we could graph this without too much trouble. We know the end behavior. Let's see if I can do this one by graphing instead of the test method. So I got a 0 at negative 1. I got a 0 at positive 1, x-intercept. And I have another one at 2. Now what's the end behavior? The first term's negative, so that means it should come down. If you want, you can get the y-intercept. That should be y is negative 2. Down, up, down. And I'm not being too accurate with my mins and maxes, so I don't really care about that. I just care where this thing is greater than or equal to 0. So let's see, according to my graph, if I graphed it right, from negative infinity to this 0, these are always x values. And then where else is it positive? Not there. From here to here, that's from 1 to 2. And then it goes negative forever. And you should get the same result if you do that by the critical number approach. All right, with rational inequalities, it's fairly similar. We're going to look at x-intercepts. We're going to also look at vertical asymptotes because it could change at both of those places. For example, let me just think. If I had a function that does this, this is kind of a typical function with two vertical asymptotes. In this case, or let's see, I guess it could do, let me give you a better example. Maybe we had something that looks like this. So over here it's positive. On the other side of the vertical asymptote it goes negative. And then in this case, just like polynomials at an x-intercept, it goes from negative to positive. So what I want to do is check both of those things. I want to check on both sides of an x-intercept, and I want to check on both sides of a vertical asymptote. Okay, so my critical numbers then, if you want, set the denominator to 0 and solve. Set the numerator to 0 and solve. And these are my test points. So just like before, I break up my real number line. There's two critical numbers, which is going to give me 3 intervals to check. And then I do some test points. F of negative 5. I'll check f of 0 here. That's an easy point. And here I'll check f of 3. Plug in 3, positive, positive, greater than 0. Plug in 0, negative, positive, less than 0. Plug in negative 5, negative, negative, greater than 0. Okay, so here is my, oh, we got to be careful. One thing to be careful about. This is a greater than or equal to, so I'm tempted to say, all right, my two intervals where it's positive are this guy and this guy. So I would say this interval and this interval is what I'm looking for. So that's negative infinity to negative 4. And I'm going to include it, because it's included here, I'm going to union that with 2 to infinity. I'm going to include it because it's included here. Okay, and like the reason we're using brackets is because what I'm saying is it's equal to 0 or greater than 0. So the 2 makes it equal to 0, right? So the 2 I have to include. However, I got to be careful with these rational functions because -4 is not in the domain of this function, right? So I can never include him. So I have to think about the brackets and the parentheses a little bit more. All right, one more. Find the critical numbers here. So I do that by, we're used to this by now, factoring x minus 5, x plus 3. Critical numbers. We can also graph this. I think the critical number approach is easier on this one. There's one vertical asymptote. Here's another. What happens on the between -3 and 5? What happens from 5 to infinity? What happens from -infinity to -3? Well, let's find out. F of -4. I'll plug it into here. -4 here gives you a negative, and a negative. Negative times a negative is a positive. 5 is always positive. F of 0, negative, positive. 5 always positive, so that's negative. F of 6, positive, 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 positive. Okay, so my solution is this interval combined with that interval, which I would write like this: -infinity to -3 unioned with 5 to infinity.